let's discuss some questions on 8085 microprocessor. The first question is from the topic of interrupt. The question asks that the 8085 microprocessor has a non-maskable interrupt as. Four options are given here. So at first, let's try to know something about 8085 interrupts. 5 interrupts are here in 8085 microprocessor. These 5 interrupts are called the hardware interrupts. The interrupts are classified into two categories. They may be maskable or they may be non-maskable also. Okay. The maskable interrupts means these interrupts may be ignored or may be delayed. The example is also given here. Look at this, the trap. The first interrupt, trap. This is only non-maskable interrupt. Okay. The rest 4 interrupts, these 4 interrupts, RST 7.5, RST 6.5, RST 5.5 and INTR, these 4 interrupts are maskable interrupts. Means without trap, the 4 interrupts may be delayed or may be rejected. So just say a little bit what is interrupt. Interrupt means when the external devices wants to interrupt the programming sequence of microprocessor, then they send signal through these pins. If you see the architecture of 8085 microprocessor, you can watch these interrupt pins are available in 8085 microprocessor. So the interrupts also may be vector interrupt as well as non-vector interrupt. Vector interrupt means this interrupts has a particular memory address. If these interrupts occur, means suppose if trap interrupt occur, it will called a subroutine that is called ISR. ISR means interrupt subroutine. So the location or the starting point of this ISR will be 0024H. 0024H. Like this, RST 7.5 003CH. These are the vector address for the interrupts which is given here. Only INTR is the non-vector interrupt. This interrupt doesn't have any particular location. And also remember this, only RST 7.5, this interrupt is ST guard. Remaining all the interrupts are label T guard. Okay. So here the interrupts are arranged according to the priority basis. If the questions come, which is the highest priority interrupt, that will be trap. Trap is the highest priority interrupt and this is also non-maskable interrupt. And only INTR, this interrupt is non-vector interrupt. And only RST 7.5, this interrupt is ST guard interrupt. Okay, so question may comes from these exceptions only. Now go back to the problem. 8085 microprocessor has a non-maskable interrupt as. I already discussed the only trap is the non-maskable interrupt. So option D is the correct answer. The next question is from the addressing mode of 8085 microprocessor. So at first discuss about the addressing modes of 8085 microprocessor. 8085 microprocessor has 5 types of addressing mode. Okay, It has 5 types of addressing mode. First one is direct. Direct addressing mode. Let's see an example like STA 05H. What does it mean? It means store the content of the accumulator with the data that is present at the memory location 05H. Okay, a particular memory location will be given. From that memory location we have to copy the data, not we have to, the processor will copy the data to the accumulator. Okay, that is ST instruction. This is the example of direct addressing mode. Second type of addressing mode is the register addressing. Second type of addressing mode is the register addressing mode. The example is the move A comma B. That means what? Move the content of the B register to the A register. A register means that is accumulator. This is the example for register addressing mode. Now, third one is the register indirect. Register indirect. Not only indirect, this is the register indirect. Remember this, the indirect addressing mode is present in 8086, not in 8085. 8085, that is register indirect addressing mode. The example is that add M. Add M means what? Add the data present at the memory location, which memory location is present on HL register pair. HL register pair, there is a data, that data is the memory location, and that memory location another data is present. We have to, means the processor will add that data with the accumulator. This is the example of register indirect addressing mode. The next type is that immediate addressing. Immediate addressing mode. Example is that ADI 04H, means it will add directly 04H with the accumulator. No involvement of other registers or memory location is here. And the last type is implicit. Implicit addressing mode. Example is RAL. Rotate accumulator right, means the bits, 8 bits are present in the accumulator. The bits will shift to the right through the content of the carry flag. Okay. Another example is that CMA. This instruction makes the complement of the content of the accumulator. So these are the little bit introduction about the addressing mode of 8085 microprocessors. So I think now we can solve the problem. Which addressing mode is represented by 8085 microprocessor LDA? I already discussed about the STA. STA means store the content of the accumulator from the memory location, suppose 9000H. LDA performs the opposite of this. LDA, suppose LDA 2000H, means load the content of the accumulator from the memory location 2008. In 2008 there is a data present. This data will copy to the accumulator. For LDA, data will copy to the accumulator for ST instruction, data will copy from accumulator to the memory. Okay. So the correct answer of this question is absolute. So the answer is absolute. Remember this, absolute and direct, both are the same. Let's discuss the next question. Program status word 8085 microprocessor consists of number of flags as. Program status word, this is called the PSW. This is also a resistor present in 8085 microprocessor. So let's see the PSW. This is PSW of 8085. PSW of 8085. Let's discuss about the bit by bit from D0 to D7. Not all 8 bits are present here, remaining are nothing. Okay, nothing is present here, nothing is present here, nothing is present here. This sign means what? After performing an operation, suppose after performing an addition or a subtraction operation, the data will be stored at the accumulator. If the content of the accumulator is negative, this S bit will 1 for negative. If the content of the accumulator is positive, the sign bit will be 0 or reset. Now see the 0 bit. If the content of the accumulator is 0, this 0 bit will set as 1. If this is non-zero, this bit will reset, means 0. Okay. Now see auxiliary carry. For addition operation, if a carry generated from the D3, D3 means what? Suppose there is 8-bit operation is there, like this 1 0 1 1 0 1 0 1. There is another number 1 1 1 0 1 1 1 1, like this. If suppose at the time of addition of these two, one carry is generated and added with the bit D4, this kinds of situation if occur, then auxiliary carry flag will set, otherwise auxiliary carry flag will reset as 0. Now see the parity 8085, remember this, works on even parity. Even parity. Parity means if the number of ones present at the content of accumulator, suppose the content of the accumulator is 1 0 1 1 0 0 0 1, number of 1 is 4, this is even number, so this case the parity flag will set as 1. If the number of 1 is odd, like this, at this case the parity will reset at 0. Now see the carry flag. After addition operation, if carry generated, the carry flag will set. If borrow generated, the carry flag will set. If no carry, no borrow, the carry flag will reset as 0. So come to the problem. Program status word of 8085 microprocessor consists of number of flags as. So we already count the flags of 8085 are sign, 0, auxiliary carry, parity and carry. So the answer is 5, option C. Let's see the last problem. The stack pointer in a microprocessor is used. In 8085 microprocessor, the registers are a accumulator, it is 8-bit register, then BC, DE, HL. These are present as pair. Each content 8 bit and the pair creates a 16 bit. Okay, and remaining registers are important registers are PC. This is program counter. It contains the address of the instruction which will execute next. Another is PSW that I already discussed. Another important register is stack pointer, SP. Stack pointer content the address of the stack, address of the top of the stack. So option A is the correct answer.